Today we shall be looking at the subject chemistry, and the topic before us is called electrolysis. At the end of the class, everyone should be able to define and explain what the term electrolysis is. Should be able to define what electrolysis is. Number two, should be able to differentiate between electrolyte, electrode with examples. Should be able to give examples of electrolyte and electrodes. Number three, everyone should be able to explain the mechanisms of electrolysis. Then 5, factors affecting preferential discharge of a ion during the electrolysis. And the last one is application of the laws of electrolysis. So sit back, get your writing material. We shall be right back. We define electrolysis as the process of decomposing ionic compound into their elements by passing a direct current through the compound in a fluid form. When we say ionic compound, they are compounds that are soluble in water. For instance, we have sodium chloride. Soluble in water, we have sodium hydroxide. It's also soluble in water. In fact, we have HCl. These are water soluble. When they dissolve in water, they form ions. Sodium ion plus chloride ion. We have sodium ion here plus or hydroxide ion minus. Then we have hydrogen ion plus chloride ion. So these are compounds which are able to dissociate or to break down their ions into their respective element or compounds. All right. It is the decomposition of a chemical compound in aqueous or molten state. For instance, like I said, it can be decomposition, meaning breaking down of this into their respective ion, or even in their molten state. They can be in their molten state, meaning they can be dissolved when heated. They melt into a fluid form when heated. The main components required for conducting electrolysis there are three components required. Components of electrolysis are 1, electrolytes. These are the chemical compounds that are in molten or in solution, e.g. sodium chloride, sodium hydroxide, HCl. Then electrode. Electrodes are otherwise known as the conductors. Then we have the cell, which is the battery that supply current to the entire system. So additionally, a partition such as an ion exchange membrane or salt bridge is also used. Although this is optional, we can use a salt bridge in some cases, or we may not need them. They are mainly used to keep the product from diffusing near the opposite direction. We can have a setup, an electrical cell like this, a system like this where we have the solution of compound, probably is sodium chloride in solution. Then we have the electrode, which are conductors that will conduct this. Then surrounded by cell, which supply the current. The positive electrode is called the anode. The negative electrode is called the cathode. So these are electrolytes, and these are the electrode, while these are the cell, or otherwise known as the battery. So this entire setup is what we call electrolytic cell, where electrolysis takes place. Electrolytic cell. So electrolysis can take place here. When this current switch is on, you see current will move into this system, thereby discharging this substance into their respective ions, sodium and chloride ion. All right. Next, Why conductors are solid substance except mercury? Like we said, these are conductors. They are made up of solid material except mercury. Only mercury is in the molten state, yet it conducts electricity. That allows electric current to pass through them. Non-conductors are solid or liquid substances that do not allow electric current. You discover that current enters into this system through the cathode like this and back to the anode and continue like this. So because these things or this material allow current to pass through them, they are called conductors. Those who are not allowed, who do not allow current to pass through, they are called non-conductors. Examples of conductors are metals such as copper, aluminum, and non-metal like graphite. Graphite is a semi-metal or is a semiconductor. We call the example of a semiconductor is graphite, which conducts electricity. It's not a metal, yet it conducts electricity. Examples of non-metal conductor are rubbers, plastic, diamond, dry wood, and benzene. These cannot conduct electricity, so they are called non-conductors. Yes? Electrolyte. What do we then mean by electrolyte? They are compounds that conduct an electric current when they are in molten or aqueous solution. I say molten state because they can melt when heated, or in solution, they have the ability to dissolve in water to form a ion. An electrolyte is an ionic compound. Of course, we have covalent ionic compound. These are substances that can dissociate in solution into their respective ion. They are called ionic compounds. When dissolved or in its molten state, allow the passage of electric current and is decomposed by it. When sodium chloride, for instance, which is an ionic solution, is in the molten or ionic state, it allows current to pass through, thereby breaking down into their respective ions, sodium ion and chloride ion, and so on and so forth. Even insoluble ion compound, such as calcium carbonate, they are not soluble, but yet they can conduct electricity in molten state. Strong electrolyte. A strong electrolyte is any chemical substance that can completely dissociate in a aqueous solution when in molten state. So if a substance can easily dissociate, can easily break down, find it easy to break down into their respective ion, they are known as strong electrolyte. While a weak electrolyte, they find it difficult, they partially dissociate, they partially break down, they find it difficult to break down into their respective ion. So they are called weak electrolyte. They are good conductors, meaning strong electrolytes such as they are good conductors. Examples are calcium hydroxide. Calcium hydroxide is an example, a very good example of electrolyte. Hydrogen bromide. Hydrogen bromide is another example because when you pass current into it, they dissociate. For instance, hydrogen bromide will dissociate into hydrogen ion and bromine ion, Br minus. Yes, we have other example as H2SO4, tetraoxosulfate 6 acid, sodium hydroxide, as we mentioned above, magnesium chloride can easily dissociate into magnesium and chloride ion, sodium chloride, HCl, HNO3, that's triazonitrate 5 acid, potassium hydroxide. These are examples of strong electrolyte. But then weak electrolyte, they partially dissociate, like we said. They find it difficult to dissociate into their respective ion, just like we have seen. Example of such is hydrogen fluoride. They find it difficult to separate into their respective ion. And other examples are organic acids, such as ethanoic acid. Ethanoic acid are examples of weak electrolyte. We haven't talked about electrolyte. Let's look at the electrode. We said they are conductors. Electrodes are graphite or metal rod or plates through which electric current enters or leaves the electrolyte. You can see current enters the electrolyte or leave the electrolyte through these two poles, otherwise known as electrode. Examples of these electrodes are called graphite, platinum, of course these are metal, gold, zinc, copper, rhodium, silver, even lead can be used as electrolyte. Now, let's look at some terms we use in electrolysis. We make mention of ions. Ions are charged atoms For instance, sodium is an atom. When it is charged, it becomes sodium ion. Chlorine is an atom. When it is charged, charge means they are broken down into their ions. It becomes negative. So we can refer to as ions as positively or negatively charged atom or radical. By the way, what do you mean by a radical? How do we differentiate between a radical and an ion? Ion is simply a charged element, meaning one singular element, such as sodium ion. This is only sodium here. Chloride ion. But when we have group of atoms such as HSO42 minus, CO3, CO32 minus, let's give these examples. HNO3 minus, these are all radicals. Radicals because they are all group of atoms. You can see sulfur and oxygen is combined, unlike when we have a single element here. So these are ions, while these are called radicals. They are group of atoms that behave like ions. They are group of atoms carrying a specific charge. So that is, by the way, ion. Then we have two types of ion. We have the positively charged ion and the negatively charged ion. The positively charged ions are called cations. Cations, meaning cathode ion. The word cations. We have two types of ions. We have the cations and what? The anions. When we say cation, it means cathode ion. Ion that attracts to the cathode ions. This anion meaning anode ions. And of course, we said our cathode is negatively charged. Our cathode is negatively charged, while our anode is positively charged. So those ions that are attracted towards the cathode must be what? Positive, because negative will be attracted by positive. So any ion that must be attracted to this ion must be positive. So cations are positively charged ion, positively charged ion, positively charged. While anions are negatively charged. I'm sure you know why. Because positive will be attracted towards negative. There's no way positive and positive will be attracted. No way. They will repel. But for attraction to take place, for a reaction to take place here, positive must be attracted. That is why we say all other ions that will come towards the cathode must be positive. That's why we say cations are positive, while anions were negatively charged, the opposite. All right. Now, cathode, like we said, they are negative electrodes which attract the cations. Can you see? Anode are positively charged electrodes which attract the anion. All right. Let's move on. Now, mechanisms of electrolysis, meaning what are the processes that occur in an electrolytic cell. Let's use this diagram to explain the mechanism in electrolysis. All right. If we have this as our electrode, and we say, let's say this is electrolysis of sodium chloride solution. Sodium chloride solution, meaning plus water. We have sodium chloride, which is the salt, and water. Now, and this refers to as our negative electrode, while this is the positive electrode, otherwise known as cathode. These are anode. Can you see? So the ions that are likely to be in this solution are going to be sodium and chloride ion. The ion that is going to be in this, when this is broken down, is going to be hydrogen and what? Hydroxide ion. Can you see? So we have 4 ions in this system. 4 good ions in this system. So what happened? The positively charged ions are this. So they are called cations. While the negatively charged ions are this. They are called anions. I hope we get that. We said cations are positively charged ions. because they are being attracted towards the cathode. So meaning for this cathode, what we will see is sodium will be attracted and hydrogen ion will be attracted toward this place. And on the other hand, for anions, which is chloride ion and hydroxide ion, they'll be attracted to this place, chloride and hydroxide ion, OH minus, because they are negatively charged. Of course, negative, like we said, will be attracted towards it. So these are called anions and cations. So what are the mechanisms of electrolysis? The word mechanism of electrolysis means when current is passed through this system, the positive ion must be attracted towards the negative electron, while the negative ions must be attracted towards the positive electron. Is that okay? Is that okay? So let's define that. Ions must be free to move, that is in molten or in solution. Positive ions move towards the cathode. We said cathode is negatively charged ion. So for positive ion, they must be attracted towards the cathode and are reduced, that is gain electron. We said reduction takes place at the cathode, reduction, REG, while oxidation takes place at the anode, oil. Reduction simply means electron gain. Say at each electrode, meaning at the cathode, reduction takes place. Reduction means electron gain. Reduction simply means electron gain, meaning at the cathode, electron is gained, while at the anode, electron is lost. Is that okay? So don't forget, remember the reaction that takes place at the anode is oxidation, while the reaction that takes place at the cathode is called reduction. And reduction simply means electron gain. You gain electron. Oxidation simply means you are losing electron. So let's take, for example, in electrolysis of molten lead bromide, a lead bromide is Pb Br2. This is lead bromide. So meaning lead bromide can dissociate, can break down into Pb2 plus, these are the ions now, plus bromine ion. Can you see? Is that clear? So in electrolysis of lead bromide, bromine will gain, lead will gain electron. Being a positive charge, we said those ions that are positively charged, they will be attracted towards the cathode. So when they are attracted towards the cathode, what happens? They will be reduced. Pb2 plus 2 electron will give you Pb. They have been reduced to Pb because they gain electron. We say reduction is electron gain. While for the negatively charged, which is bromide ion, will lose electron. When it loses, become bromine plus an electron. Is that clear? So in this case, you balance it up by putting 2 here, 2 here. Is that okay? So in this case, oxidation has taken place. Oxidation here, because it has lost electron. Bromide ion has lost electron to become bromine atom. Lead has gained, can you see, to become lead solid, lead as a substance. Now, let's look at other examples of the mechanisms of electrolysis. Other examples such as copper 2 tetraozosulfate 6. We can have this example. Okay. CuCrO4. This is copper 2 tetraoxochromate 6. Chromate is a color substance. Of course, when it dissociates, it will give you Cu, which is positive ion, and Cr, that's chromate, O4 2 minus. So this is the cation, while this is the anion. Is that okay? Copper is blue in color. Of course, you know copper ion is blue in color. Why this is yellow in color? So in this case, what happens when you have this in solution? The positive ion will be attracted towards the negative because it's positively charged. So it will be reduced. When copper is reduced, Cu2 plus, you know, when it comes to the cathode, what happens? It will gain electron, 2 electrons, to become copper solid. Is that okay? So we said reduction has taken place here because electron is gained to become copper. What about this? Negatively charged will be attracted towards the what? Anode. And it what? Lose electron. Is that okay? It will lose electron because it is oxidation. Can we move on? So just like we said, copper ion will be transported towards the what? Being a positive ion, will move towards the cathode. And cathode ion is negatively charged. So it will be attracted. You will see the blue coloration because copper ion is always blue. It will be moving. You see this environment will be blue in color because the molecules of copper here, ions of copper will be attracted towards it, showing the color blue coloration because they will be discharged at the cathode. When they are discharged, meaning they gain electron to become copper solid. Now, the negatively charged ion is the chromate, which is yellow in color. At this point, you see yellow coloration here, meaning they have been attracted towards the anode, thereby losing electron. All right, so this arrangement or this movement are called the mechanisms of electrolysis, meaning the ability of the negatively charged to be attracted towards the positively charged, and the positively charged to be attracted towards the negatively charged electron is what we call the mechanisms of electrolysis. Now, let's move on. Let's look at preferential discharge of a ion. From the word preferential discharge means which ion do we prefer at each electron? What are the conditions that determine the discharge of a ion in an electrolytic cell? All right. Let's put up a diagram. We said if we have electrolysis of brine, for instance, electrolysis of brine, when you say electrolysis of brine means sodium chloride, brine, meaning sodium chloride solution, meaning sodium normal table salt. So in electrolysis of brine, what we have is water. Then we have the next thing we have, the other substance we have in combination is sodium chloride. So what are the likely ion here? Water will give us hydrogen ion plus hydroxide ion. Can you see? Then this one too will dissociate into sodium ion and chloride ion. Can you see? So meaning in this brine solution, in this electrolysis, we have 4 types of ions that are competing. 4 types of ion that are going to be discharged at each electrode. Don't forget, we said in an electrolytic cell where we have the electrode, negative electrode, which is the anode, the cathode, and the positive electron, which is called the anode. These electrons are they are in this solution. They are all scattered around this solution, but they are going to be discharged at each end of the electrode. How? What are the conditions that tells you that it is hydrogen that will be discharged here, or is the chloride that will be discharged? What are the things? We said preferential discharge. We're going to look at some of these conditions that make this ion to be discharged. Number 1, before we move on, we just said that all positive ions, which is the hydrogen ion and the sodium ion, will be attracted towards the negatively charged ion, which is the what? The cathode. That's the mechanism, right? But the two cannot be discharged at the same time. It's not possible. One must be preferred to another. Hello? We have these 2 ions competing at the cathode to be discharged at the cathode, but one must be preferred to another. So when hydrogen and sodium compete, what is the condition that tells you that, oh, I will prefer hydrogen to sodium? That's the preferential discharge we're talking about. Then let's look at the other side too. On this side, we have the hydroxide ion and the chloride ion. Both of them are coming here to compete. Which of them will be preferred to the other? These are the conditions that must be spelled out. They are based on conditions. Why would anode prefer hydroxyl ion to chloride? They are based on conditions. So those are the conditions we want to look at now. So preferential or selective discharge of a ion. In aqueous solution, water ionized, water, just like we said, water will ionize, meaning will break down into hydrogen ion and hydroxide ion. More than one ion may compete for discharge at each electrode. We said that. Example, electrolysis of copper 2 sulfate. Copper 2 sulfate is CuSO4 with platinum electrode. So copper 2 sulfate solution, don't forget solution, not just copper 2 sulfate. In copper 2 sulfate, looking for a place to write that, CuSO4 solution, meaning copper 2 sulfate is dissolved in water. So the likely ion here is Cu 2 plus and SO4 2 minus. Can you see? 2 ion go to break down. Then this one will give you hydrogen ion, as usual, water plus hydroxide ion. So 4 ions are going to compete, just like we said above. 4 ions are competing. The positive ions are hydrogen ion and copper 2 ion. The negative ions are hydroxide ion and SO4 2 minus ion. So when they compete, which one will be preferred to another? These two, don't mind you, copper 2 ion and hydrogen ion are positively charged. So because they are positively charged, they will be attracted towards the negative electrode, which is called the cathode. These ones are negatively charged, SO4 2 minus and hydroxide ion, OH minus. They are negatively charged. Automatically, they will be attracted towards the positive charge, which is called the anode. Yes. So the factor that determines their charges they are divided into just 3. Number 1, position in the electrochemical series. What are the positions of this ion in the electrochemical series? What are the positions of this ion in the electrochemical series? We said electrochemical series is an arrangement of a ion in an order that tells you one ion can easily discharge than the one that follows. So we have, for instance, we can have electrolytic series of like this for positive ion. Positive ion, we say cations. We have something like this: copper, potassium, sodium, hydrogen, zinc, and so on and so to make up to mercury or gold, Au, like that. Let's take this as an example of our electrochemical series. Then we have for anions. Anions are negatively charged. Anions are negatively charged. We have OH minus. We have chloride ion. We have NaOH ion. Then we have SO4 2 minus. So you can see these are negatively charged. This one tops the list. This one is the lowest in the list for cation. Why for anion? Hydroxide ion top the list. Sulfate ion is the lowest in the list. Exactly. So we call this electrochemical series. Electrochemical series. They are longer than this, but I will just give you a few of this example. So let's look at the conditions here. Meaning, for a cation to be discharged, one of the conditions is that you look at the position. Look at this is on the first position. Potassium is on the first position. Why this is on the 1, 2, 3, 4, 5? Gold is on the 5th position. For anions, hydroxide is on the first position. Chloride is on the 2nd position. So you can see the position of these ions in the electrochemical. But the condition is that for cation, what are cations? These are cations. For cations lower in the series are easily discharged, e.g. silver over potassium. So if we have this, let's say this is silver, Ag, and this is Au. If we want to produce this silver, this is this. So if you look at silver, we just included silver now. Look at silver and potassium. And we said cations that are lower in the series will be preferred than the one above it. Between potassium and silver, which one is lower? Silver is lower, of course. So when we have both potassium and silver competing in an electrolytic cell, silver will be preferred to potassium. Potassium will be knocked off, while silver will be discharged. Are we getting it? That's for cation. How about the anion? The reverse is the case. For anion that are higher in the series are easily discharged. Look at anion that are higher in the series are easily discharged. For in this case, when we have hydroxyl ion over sulfate, can you see? Look at hydroxyl ion and sulfate. Which one is higher? OH is higher. Compare when these two are competing. So automatically this one will be discharged, while this one will be in the solution. Those are the conditions. For cations that are lower in the series will be preferred to those ones that are leading or topping the list. Then the reverse is the case for anion. Those ones that are higher in the series will be discharged compared to the one that are least. So if I may ask, if we have two ions such as hydroxyl ion and chloride ion, which one will be preferred? Which one will be preferred? Which one will be preferred? Which one will be discharged first? Of course, it's hydroxyl ion because it's leading. If you compare this and this, it's the top on the list. So for anion that are higher in the series, which is OH, will be preferred to chloride ion. In the case of when we have sodium and hydrogen, hydrogen will be preferred to sodium because hydrogen ion is lower in the series because it's a cation, will be discharged compared to this. Number two condition is concentration. What is the concentration of this ion? Higher concentration can favor discharge. E.g., concentrated HCl give chloride advantage and not oxygen at the anode. You get what I'm saying? If we have a solution of concentrated HCl as the electrolyte, we have electrolysis of concentrated H. You have the condition concentrated conc HCl solution. What are the ions that are present? HCl and water. I told you it's a solution. 4 ions must be present. We have HCl, which discharges to hydrogen and chloride. Then we have hydrogen and hydroxide. Can you see? So this and this, they are the same thing. They are hydrogen ion. Of course, the two will go to the cathode. Are you getting me? And hydrogen, since they are the same thing, only one is the same. You know, hydrogen will be discharged. That's no. But for this, chloride and OH, which one will be preferred? These two are competing. Look at, for anion, look at it. OH and chloride. Which one will be preferred? Of course, if you look at the position based on the first, this one is supposed to be preferred, OH. But we are looking at the second thing now, the concentration, which is the condition. Concentrated ion, meaning in this solution, concentrated HCl, meaning chloride is concentrated. So for a concentrated chloride, it has an advantage over the OH. Is that okay? So because this solution is concentrated, chloride ion will be preferred. Unlike when we say the position on the electrochemical series, if we are to go by position, this will be preferred. But because it's a concentrated solution of HCl, chloride ion will be preferred. Can we see the second condition now? Now let's look at the third condition. Nature of the electrolyte. When we say nature of the electrolyte, what is the substance that makes up the electrolyte? The electrode rather. What is the substance that made up? We say electrodes are conductors. And they are mostly made up with metals. There are some metals that have affinity. When we say affinity, love for a specific ion. Meaning when they see a particular ion, oh, they attract them. They have a particular preference for them. They have a particular preference for them. You know, regardless of their position, regardless of their concentration. They don't want to care. It's just like your father is a VC and then you score 190 in JAMB. It's automatic. Don't be surprised that your name will top the list because your father is number one. He doesn't want to care the condition because of that affinity, the bond between you and your father. So regardless of the conditions, maybe position, concentration, as long as some elements are made up of the electrode and this element have a particular love for this ion will be preferentially discharged in the solution. So let's look at, okay, inert electrode. When we say inert electrode, they are electrodes that don't react. They don't react with a ion. They don't react. Example is platinum. They don't react. Platinum is inert. They don't react. They don't want to know which element is in the solution. They just do their job. Then active electrode can participate. Active electrode, e.g. copper. Oh, when copper sees a particular ion in solution, they react. They react. So copper electrode in CuSO4 solution. When we have electrolysis of copper 2 sulfate using copper electrode, electrolysis of CuSO4, don't forget we said solution. So we have Cu plus and SO4 2 minus. Then in solution, that is H2SO4. That is H2O, meaning hydrogen ion and hydroxide ion. So these two solutions, these two ions are competing, copper and hydrogen. Sulfate ion and hydroxide ion, they are competing. And mind you, the electrode we are using is copper electrode. You see, you are using copper electrode inside copper 2 sulfate solution. Can't you see? Can't you see that familiarity? The solution here is copper 2 sulfate. And the electrode you are using is copper. Copper. Can't you see that it's automatic that copper will prefer copper? Because copper ion is found in solution, copper will be preferentially discharged compared to hydrogen in the solution. Because of the affinity, because of the bond between them. So that's why we said active electrodes such as copper, we have a strong affinity for copper in the solution. Look at the cathode, copper will be discharged. But if you are to go by position, look at, if you have to go by position between copper and hydrogen ion, of course, you know that hydrogen should be discharged because hydrogen is lower in the series. But they don't want to obey that condition anymore. But because of the nature of electrode that makes up the electrolysis. Another example. So anode, at the anode, copper will be discharged because copper has a strong affinity for the copper electrode. With the two electrodes we use is copper-copper. Is that okay? So copper will gain electron to be deposited as copper ion, and in this case we will lose electron to become copper ion inside the solution. So that is why this electrolysis is used in the purification of metals such as copper. So if you want to purify copper ion, you use them as the electrode. Because in this case, copper will dissolve inside the solution to be purified, to be deposited at the cathode as pure copper. You know, by so doing, you are purifying copper. You see, this is dissolving from the anode into this, you know, to be deposited as a new element, new copper element. So in that case, copper is being purified from impure copper, as using impure copper as anode, and the pure copper that will be deposited at the cathode become pure in that electrolysis. Yes? All right. Let's look at examples of some electrolysis. I want to round up by giving you some of the examples. For instance, we say electrolysis of water. Electrolysis of water is otherwise known as electrolysis of concentrated H2SO4. Electrolysis, example of electrolysis. Electrolysis of water, or otherwise known as electrolysis of concentrated H2SO4. H2SO4. When we say electrolysis of water, why electrolysis of water? We call it electrolysis of water because water is being discharged as a product at the end of this electrolysis. Why? Because at the electrode, we have hydrogen will be provided, will be produced, and oxygen will produce, or hydrogen and oxygen will be produced. Hydrogen will produce at the cathode, and then at the anode, oxygen will produce at ratio 2 to 1. Ratio 2 to 1, meaning 2 of the hydrogen to 1 of the oxygen. And when we see hydrogen producing at the ratio of 2 to 1, automatically this is H2O. If you look at the ratio of hydrogen to oxygen, it's called H2O. So automatically it's water. Water will be the end product of that. So that's why we call this electrolysis of water. So what are the requirements, or what are the ions that will be discharged? We said we have H2SO4 and water. So the ion presence is hydrogen ion plus SO4 2 minus. Then this is hydrogen ion plus hydroxide ion. So going by the preferential discharge, we said these are the cations, while these are the anions. Of course, hydrogen and ion, they are the same. Hydrogen at the cathode, hydrogen ion will gain electron, meaning one electron to be discharged as hydrogen. That's reaction at the cathode, cathode ion. Exactly. But hydrogen does not occur as a single element, but rather it combines with other hydrogen to give you hydrogen gas. Is that okay? That's the reaction at the cathode. How about the reaction at the anode? At the anode, we have two ions, hydroxide ion and sulfate 6 ion. And going by what we say, preferential discharge, which of the ion will be preferred? Of course, it's going to be this, because this is higher in the series compared to this. We prefer this. So when this is preferential discharge, it will lose electron, meaning OH minus, losing electron will give you OH plus 1 electron. So OH does not just occur on its own, but rather it's combined. OH plus OH will give you H2O plus oxygen if you balance the equation. So you balance, let's move on here so that we can be up. Mind you, oxygen does not occur as a single element. This is just an oxygen atom, but rather it combines with other oxygen to give you oxygen atom. Is that okay? So these are reaction at the anode reaction. So by the time you carry out the experiment, you discover that hydrogen is produced at the anode, while hydrogen is produced at the cathode, while oxygen is produced at the anode. So by the time you look at the ratio of oxygen to hydrogen, you discover the ratio is ratio 2 to 1. That is why it is called electrolysis of water, or electrolysis of brine. Electrolysis of water, or electrolysis of concentrated H2SO4. So we have come to the end of the class electrolysis. Please, if you have any question, go to the comment section and drop your comment. Then please subscribe to this channel. Thank you.
Hi, if you have not subscribed to this channel, you can do so in 5 seconds. 5, 4, 3, 2, 1. And don't forget to hit